Okay, in this tutorial I'm going to talk about Scilab. Scilab is a powerful mathematical programming language which is quite similar to MATLAB. If you learn Scilab, you basically know MATLAB. You can take a Scilab program and convert it to MATLAB in a matter of 5 or 10 minutes. And in fact, there's an automatic translation program that will convert MATLAB files into Scilab files. So I like Scilab because it's free. You can download it yourself at www.scilab.org. Today we'll be looking at this tutorial. All right, the first several pages we can skip. All right, and the first window that we want to look at is this window here. Let me open up my copy of Scilab. Of course, your Scilab path will be different. All right, this is the command window that's referred to here. That's what Scilab opens up into. And let me put these side by, whoops, that's not what I want to do. Let me move this up so I can put the Scilab, the tutorial and the console in the same time. Okay, so you can see this. Now I can type commands in here just like they did here. And I encourage you to go through this tutorial and type the commands that they show. For instance, 57/4, and they'll show the different answers. This will give you practice in entering formulas. Now, this way of representing numbers and operations is very similar to Excel, 2 + 9 to the power 5. Okay, you would type the same thing in Excel. Of course, in Excel, you begin every command with the equal sign. That's not necessary in Scilab. Okay. If I want to recover my previous typing, I can hit the up arrow. It's very convenient. As I said, go through here and type the things that the commands they have here, and you will learn how these things work. Okay. Notice that constants like pi and e are preceded by percent signs, which identifies them as special variables. You do also have variables in Scilab, which we'll see shortly in this document. I think I better zoom this a little bit. Where's my zoom? Because it's here. Okay. There we go. Okay. There are functions that you can use in Scilab, very much like Excel. The function names may be different. To find functions, there's a very good help. Go to the help button here. And for instance, if I want to know something about factorial, I can type in factorial here. And it will find for me factorial. It's very important to learn how to use the help in any sort of software. Actually, if you can't find the answer in the help, you can even use Google. That may be enough to find you the answer. There's a lot that's been written on this software. There's a lot of documentation available. So please use the help button or use Google on the web. Right, some of these things are not necessary. Let's see. All right. The other important thing sorry, I was interrupted. The other important thing is that when in using Scilab, you can type commands into this window. You can also write programs. Now, programs are hugely useful in doing large and complicated computations. I've been showing you Excel for certain simple numerical applications. Once you get into real-world computations in engineering, you don't use Excel. You will certainly use something like Scilab or MATLAB. So the way to start the to write programs is to use this application called SciNotes. So I can go to Applications, sign notes. Now notice here there's a MATLAB to Scilab translator. I'm not going to talk about this, but if you write a program in MATLAB, you can translate it to Scilab using this automatic feature. All right. So here I'm going to go to sign notes. And here is where I can type programs in. For instance, if I wanted to type in the same command, 2 plus 9 to the power 5, and I ran this program, I have to save it first. So if I save and execute, and I'll have to save it as something, so I'll just save it as test. And it actually did compute this number. It doesn't show the result. We'll see in a minute how to show the results. Well, I can show you now. I can put, for instance, I could let that be A, and then here I can put DISP. That means display. So if I run this program, it will show the same result. I'm getting a little ahead of myself, but I do want to emphasize that you can type commands directly into the window, or you can open this, for applications, you can open this sign notes window and type in commands here and execute this as a program. Okay, so let me go back to the tutorial. Okay. All right, so here they talk about some things about the editor. All right, so you could type this into the editor and then hit the execute button, and it would show you some things. So I do encourage you to type this in and see what happens. But that's exactly what you do. You type these commands into the display window here, and then you hit this button and see what happens. Notice that you can comment your file if you want to explain what you're doing to yourself. The computer doesn't understand this calculation of 10 terms, but you can understand it. It's just kind of commentary for you to understand the program. Okay. All right, now you can also, there's also a graphics window. Again, you can just go through and type in the window the things that are mentioned here, and you get the same results. This tutorial is a very good way to feel your way around the program. Go ahead and go through all of these things. Here's the help window that I showed you before, and you can look up functions, etc. I'll show you that again. The help window here. If you want to look up a specific name, you go here to the magnifying glass. Okay. You don't really need to worry about Windows management. Programming is important. This is what you do in the sign notes window. It talks about variables and typing in variables and how you arrange them. A variable can have letters and numbers in it. So this is a variable. This % pi means the mathematical number pi, like we saw that before. So he named this variable pi by 2, which means pi divided by 2. Okay. You can define functions. So I would encourage you to type this in. I'm not exactly sure what this is supposed to do. Oh, I see. So it's an exchange rate. You have euros to dollars conversion. Okay. And once you define a function, you can find values. please just go through and type in these commands, and I think it will show you what's going on. Okay. This also is important. This is how you type in vectors and matrices. If you've used Wolfram Alpha, it's a little bit different from that. You don't use curly brackets. Instead, you use square brackets to denote the vector or matrix, and you use semicolons to separate the different rows. So this is 3 in the first row, 2 in the second row, 5 in the third row, and that's how it displays for you. So this variable v denotes this column vector. Okay, if you put commas between them, they're in the same line. Okay, you can put either commas or a space. It doesn't make any difference. Here they put commas between the numbers. Here they simply put spaces between the numbers. That's the same. It does the same thing. The semicolon means you go to a different line. Okay, I do think most of this is self-explanatory. Type in and see what happens. This is the DISP function that I showed you in the window up here, in the sign notes window. I'm not sure why it's not coming up. Oh, that's because it's here already. Yeah, it's the same function here. If I wrote it, instead of that, if I wrote this and I put quotations like that, then all it would do is show me, it would show me A, because here I'm telling it to display this string of letters rather than this variable. Okay. Loops are also extremely important. That's probably the principal reason why we use programming, to automate repeated tasks. So here's a way to generate a series of numbers using colon. The 2 tells me the increment between the steps. I can have a negative increment. This tells me step by step what happens, what these statements correspond to. This is a loop. What this does is it will assign values to this vector u. And then in the end, it will show all of the indices and the vector values u of n. Here, there's a different type of loop called while. The loop that we will most often use is this for loop. This for loop says that this variable n starts at 1 and it goes up to 20. That's what this says here. So type in the commands and see what happens. Right. So the same thing here. It explains what you type in and what it means. You also have something called an if statement, which tells the computer makes a logical test, and if you pass the test, it will do one thing, and if you don't, it will do another thing. Okay. Notice the difference between double equals and equals. Equals means that the variable on the left should be set equal to the value on the right. Double equals means I'm testing whether or not the two values are equal. You see, this x double equals y means it's testing one by one to see if the values in x are the same as the values in y. 1 is not equal to 5, so I say false. 2 is not equal to 3, so I say false. 5 is equal to 5, so I say true. Okay. Again, go ahead and type all of these examples and see what's going on. All right, here's the conditional statement that I referred to. Let me make this big for now because we're not referring to the other. Okay. All right, so here's a good example of how you would use the if-then statement. You have a rule that is different depending on conditions. And this is how we can how we can program this rule. And you can see how they're using if statements. If you get 3 6s, you win 20. If you get 3 identical values, then you get 10. If you get 2 identical values, you get 5. Plotting is also an important part of the program. You can make very nice plots with lines with different colors and different markers on the lines. Okay, and here's some examples of plots. Okay, I could just type, for instance, I could type this into my, actually I think I can do that. I can do my select text. I can just select this text and copy it with Control C and go into my Scilab window and, whoops, doesn't like it. There we go. Okay. And it will plot that value. Okay. So go through and do these plots. I would say that pretty much covers the important things that we're going to want. How to input vectors and matrices, how to arrange loops, how to use the if statement, and basic plotting. That's what's really going to be important for us in this class.